Hey there, Earth Scientists. This is Mrs. Gibbs here with you. I'm going to be helping you with assignment 4.09. I'm turning it into a quiz so that you do not have to turn in this worksheet. But what I request is that you download the worksheet, which is next to this video in your lesson. Again, it's 4.09, and follow along and write things down as we go so that you can take the quiz and do well on the quiz. So you will be taking a quiz instead of turning in this worksheet, but you are responsible for recording your information on this worksheet so that you know what's going on. So let's get started. So as we learned in Class Connect on Monday, we have new seafloor that's being added all the time at the Mid-Atlantic Ridge. So what's happening is, if I can show you a picture here, we have this magma from under the earth coming up and bubbling over, and we have this new crust as it hardens. Now, the mantle with the convection currents is causing the crust on this side to move this way, and the crust on this side to move this way. So we have this new ocean floor actually being created, and then the crust moving. So we have the seafloor spreading, it's getting wider, and so we're going to talk more about that today. It says that close to the ridge, rocks are younger, and as you move away from the ridge, rocks become older. The rate of seafloor spreading has not been the same over time. In this activity, you will calculate the average rate of seafloor spreading and determine when the seafloor started to spread. So number one, where would you find the oldest sections of seafloor? Near the continents, here near North America and Africa? Or would the oldest sections be in the middle? So think about where the seafloor, new seafloor is coming up, and the question is asking where the oldest sections are. So write that down. Next, we're going to take a look at this map and look at the coasts of North America and Africa and see how old these are and how fast they're moving. So the numbers here, it says, are the ages in millions of years. So they've dated it with radiometric dating, and they know that this line, for example, is 20 million years old. Here is 35 million years old, 55 million years old, etc. So again, that's a hint to where's the oldest? Take a look at the map. So what is the scale of this map? Our scale is right here. So 1 centimeter equals how much? Okay, next we're going to choose a strip of seafloor rock. What is the age of the rock? Let's go ahead and do the 35 million years old one. MYO stands for million years old. And I'll show you why we're going to do that. We're going to measure, and it's going to be easier to measure using one that is closest to a centimeter here. So question number 4, it says use your ruler to measure the distance of the strip from the Mid-Atlantic Ridge. So I have an online ruler here, but in order to use my online ruler, I can't rotate the ruler, so I'm going to rotate the picture instead. And we are going to measure from the Mid-Atlantic Ridge to the 35 million years old. So hopefully you can see I have the starting point here at the Mid-Atlantic Ridge, 35 million years old. I'm looking at this strip right here, and it's pretty much exactly 1 centimeter, okay? So this is going to be easier for us. It's exactly 1 centimeter. So let's go ahead and write that in. Next, you need to use your calculator. You're going to multiply the answer to number 4 by 405. Why? Because we're measuring in centimeters, but 1 centimeter actually equals 405 kilometers. So our answer to number 4 is 1. So what's 1 times 405? Hopefully you can do that in your head. 405, right? So that's 405 kilometers from the Mid-Atlantic Range to the 35 million years old strip of rock. Okay, now we're going to do some more math. And I am not going to be doing all this math for you, but I am going to walk you through how to do it. So this is where you need to be writing down your information on your own sheet of paper. But please make sure that you're using my calculations here so that when you take the quiz, the answers for the quiz match up. Okay, so you should be using the fact that we are doing the 35 million years old strip, which is 1 centimeter, which is 405 kilometers. So please use that information to complete the rest of this. So number 6, you're going to find out how fast the seafloor is moving from the ridge on one side. So let's use a calculator and divide the answer to number 5 by the answer to number 3. So we're taking 405 divided by 35 million years old. So what's the answer going to be? You do the math. 405 kilometers divided by 35 million years old. So you will get an answer here, which again you need to calculate. And this is going to be your rate. This is how much it moves every million years. Okay, this is how much it moves every million years. Next, you're going to take this answer and multiply it by 2. Okay, because we're only looking at one side here for number 6. But now we want to know how much wider the whole seafloor is getting. So it's not just getting bigger on one side, it's getting bigger on both sides. So we have to multiply our answer for number 6 by 2, which gives us the full distance it's expanding on both sides. So it would be the answer to number 6 times 2. So I'm going to put answer 2 there. Okay. Next, number 8. So the distance between point A and point B, or the coasts of Africa and North America, is 4,550 kilometers. So use your answer for number 7, so whatever answer you got here, and find out when the Atlantic Ocean began to open. So take 4,550 kilometers divided by the answer you got here to number 7. Okay, and that's going to be how long ago it started to divide. So I'm going to put answer 3 there. Now, look at the geologic timeline. So let's see if we can find a geologic timeline here. And we can find a whole bunch of images here. So if we were to look at this, any of these images, that's not a good one. Let's find another one here. Possibly this one. Okay. If we are calculating when that began to open up, we're going to find that amount of time on our time scale. And it is asking during which period was that? During which period did it start to divide? Okay, so again, please look at your time scale. Let's find an even better one. Okay, so the periods are over here on the right. So knowing how long ago it began to divide in millions of years, find the period that matches up with it here. And then 10, 11, 12, and 13. I am going to have you do some more math there on your own. So let's see if we can find the rate of seafloor spreading in centimeters per year between North America and Africa. So we're going to take our answer to number 7 times 1,000 times 100 divided by 1,000,000. And that's how much it's moving in centimeters per year. So our answer to number 7 is how many kilometers every million years. For number 10, we want to find out how many centimeters per year. So again, please follow this exactly. Keep in mind, we are not using the actual number 7. We are using whatever we calculated for our answer to number 7 times 1,000 times 100 divided by 1,000,000. Okay, and then we're going to use some of that information to calculate how much that's actually increased since you were born. So let's do that for number 11. Follow the directions here. Let's say the average person lives to be 82. So how much has it moved in 82 years? You'll put that there. And then the last question is number 13. how much closer were the continents when Columbus crossed the Atlantic in 1492? So first you have to find out how many years have passed since 1492. So how do we do that? What year is it? 2019 minus 1492. So how many years is that? Okay, and then we're going to use that number and use our rate here for number 10. So hopefully that helps you get started. Again, you will be taking a quiz based off of this information, and then you do not have to turn in this assignment. Please make sure your math is good, double check it, make sure you're reading each question step by step. If you want to listen to this video again, go back, pause it when there's math, and then restart it to make sure that you're following along. Thanks, guys.